Light. Laws of reflection. You know that light travels in a straight line. Light hits objects and bounces back. When this light reaches our eyes, we can see the object. You also know that if an opaque object comes in the way of light, the object blocks light and we get a shadow. Now, we are going to study the reflection of light. If you stand in front of a mirror, what you see is an image of yourself. This is a reflection. I'm sure you know what a reflection is. The question now is, how is reflection formed? A reflection happens when light strikes a shiny object and bounces back. How can we make light reflect? Well, one way is to make light fall on a shiny surface. A shining stainless steel plate or a steel spoon can also change the direction of light. The surface of water can also act like a mirror. You must have seen the reflection of trees or buildings in water. Here is how you can see reflection happening properly. Take a simple electric torch. Stick a piece of paper having 3 slits over the glass of the torch. Now, fix a plain mirror in upright position in front of the torch. Now make the beam of light from the torch fall on the mirror at an angle. What happens to the beam of light? The mirror changes the direction of light that falls on it. Move the torch slightly to one side and then the other. Do you see the way the direction of reflected light changes? Now, you know how light gets reflected from a plain mirror. Here is an activity to study reflections. You will need a pencil that is sharpened at one end and a plain flat mirror. Hold the pencil in an upright position in front of the mirror. What do you see in the mirror? You can see the reflection of the pencil in the mirror. The pencil that you see in the mirror is also known as the image of the pencil. The actual pencil that you're holding is known as the object. So now, move the pencil closer to the mirror. Does the image move closer too? Yes, it does. Now, move the pencil to each side. Does the image move along with the object? Yes, it does. Turn the pencil a little. Hold the pencil in a slanting position. Does the image also do the same? Yes, it does. What did we study in this activity? We know that the image moves just as the object moves. When the object comes closer, the image comes closer. When the object tilts, the image tilts. The image follows the object. But how much does the image actually move? For that, we need to do another activity. For this activity, you need a small colorful object and a chessboard. If a chessboard is not available, you can draw an 8x8 grid on a chart paper and color in the alternate squares so that it looks like a chessboard. Well, so you have a chessboard and you have a small colorful object. This is the object that we have chosen for this activity. Now we will keep the mirror upright and place the chessboard in front of it. Keep the object on the third square from the mirror. Look at the image. The image is also on the third square from the mirror. Now, shift the object one square behind to the fourth square. What happens to the image? The image also shifts one square behind and moves to the fourth square. You will find that the image is at the same distance behind the mirror as the object is in front of it. You can verify this by placing the object anywhere on the chessboard. We have seen so far that the distance of the image behind the mirror is the same as the distance of the object in front of the mirror. The image also looks just like the object. But have you noticed one interesting difference? Stand in front of a plain mirror. Make a friend stand next to the mirror so that the friend and your image are both looking at you. Now, raise your right hand. Your image raises a hand too. Make your friend copy the image's action. Your friend has to raise his left hand to match the image. Now touch your left ear. Make your friend match what your image is doing. Your friend has to touch his right ear. You will find that in the mirror, the right appears left and the left appears right. Thus, the sides are interchanged. But understand that only the sides are interchanged. The top and bottom remain the same. The image doesn't appear upside down, does it? So, it's only the sides that are inverted. This is also known as lateral inversion. Now, write your name on a piece of paper and hold it in front of a plain mirror. Can you read it? Now take the same paper and turn it over. You can see the outline of the letters you have written. Trace them over. You can't read it properly. But hold it in front of a mirror. You can read it properly now. That is because the letters and the whole word is laterally inverted in a mirror. You must have seen an ambulance on the road. If you look at the front of the vehicle, you will see that the letters are written so that they are laterally inverted. Why is that so? When the driver of a vehicle ahead of an ambulance looks in his rearview mirror, he can read ambulance written on it and give way to it. Why can he see it properly? Because the laterally inverted word gets laterally inverted again in the reflection and becomes readable. Here's something interesting. What happens when you take selfies? Even there, the text gets laterally inverted. Check when you can. When you take a regular photo, the text is okay. But when you do it in selfie mode, laterally inverted. We have understood what reflection is. Now let us try to see what the laws of reflection are. Here is an activity that you can try out to understand the laws of reflection. For this, you will need a sheet of white paper, a flat surface like that of a table, a plain mirror, a torch, and a black paper. You will also need sketch pens of different colors and 2 long straight sticks. Spread the sheet of white paper on the flat surface. Make a small slit in the black paper and stick the black paper to the torch. Hold the plain mirror upright on the table. Hold the torch about 15 centimeters away from the mirror. Now make the room dark. Switch on the torch. A beam of light from the slit in the paper falls on the mirror at an angle. You can also see the reflected ray. Keep a stick aligned with the incident ray and another stick aligned with the reflected ray. Then, with any sketch pen, draw lines where the sticks are. The original ray of light that falls on the mirror is the incident ray. The ray that gets reflected is the reflected ray. Draw a perpendicular to the mirror at the point where they meet. This perpendicular is called the normal. The angle that the incident ray makes with the normal is called the angle of incidence. The angle that the reflected ray makes with the normal is called the angle of reflection. Using a protractor, measure the angles. We measure the angle of incidence and write it down. We also measure the angle of reflection and write it down. We find that the angle of incidence is equal to the angle of reflection. We do this a few more times and we find that each time we get the same result. What did we just learn? The angle of reflection is equal to the angle of incidence. The incident ray, normal, and reflected ray lie in the same plane. The incident ray and the reflected ray are on opposite sides of the normal.
If you like our videos, do share them and subscribe to our channel. If you want awesome quizzes, write to us. Keep watching and keep learning with Walnut.